Linear motion. According to Britannia.com, linear motion is one spatial dimension. Furthermore, linear motion must also be along a straight line with a constant velocity until there is a subject to an opposing force, which will slow the linear force. For example, an example of linear force would be gravity, as it pulls directly straight down. Linear motion can be measured by one of two factors: distance and displacement. According to physicsclassroom.com, distance is a scalar quantity that refers to how much ground an object has covered during its motion. A scalar quantity refers to a measurement which has magnitude to show how big, fast, or far an object is, but does not provide a direction in which the motion has been taken. An example of a scalar quantity would be 1 meter, which is a distance, as it provides a size but no specific direction in which the size goes. Distance provides a measure of total distance and path and the path the object took from start to finish, for example, as seen in the image above. So this would be as we can see in the far left hand corner, the distance is the whole route it took. Whereas displacement is a vector. Unlike scalars, vectors have both size and magnitude, showing both how far and in what direction an object is travelling. An example of a vector would be displacement. According to physicsclassroom.com, displacement is a vector quantity that refers to how far an object how far out of place an object is an object's overall change in position, showing that displacement is a vector as it presents both the distance in the form of size and direction in which an object has travelled from its original position, therefore making displacement a much more useful measure for linear motion, as it provides more data on the total distance covered from the starting position. As going back to the image in the far left hand corner, we can see that from start to finish the displacement shows directly how far it gone from start to finish, ignoring the whole route. Just from start to finish, the distance between them would be the green line. Another example of scalar and vector quantities would be speed, velocity and acceleration. These three factors are all closely connected together, greatly impacting at one another. Firstly, I will present speed and velocity. According to bbc.co.uk, speed is another scalar quantity. It is the rate of change in a distance travelled by an object. While velocity is a vector quantity, it is the speed of an object in a particular direction, highlighting that speed is scalar as it only presents size in the form of how fast an object is travelling in meters per second, whereas velocity is a vector as it presents both size in the form of distance and direction of motion. For example, if you said an object is travelling at 60 miles per hour, that would be speed, as it only presents size, no direction. However, if you said 60 miles per hour north, that would be a velocity, as it provides both size and direction of motion, which is shown as in meters per second in direction. In response to acceleration, according to physicsclassroom.com, acceleration is defined as the rate at which an object changes its velocity. An object is accelerating if it is changing its velocity, therefore making acceleration a vector quantity, as it poses both magnitude and direction, with the magnitude coming from the change in speed per given unit of time, and the direction coming from whether the acceleration is positive or negative, with a positive acceleration being linked to speeding up as velocity increases, and deceleration being linked to the object slowing down as the velocity decreases. Acceleration is calculated by dividing change in velocity by time taken, with acceleration being measured in meters per second squared. The final set of scalar and vector quantities are linked to linear motion, being impulse and momentum. According to physicsclassroom.com, momentum can be defined as mass in motion. All objects have mass, so if an object is moving, it has momentum. It has its mass in motion. The amount of momentum that an object has is dependent upon two variables: how much stuff is moving and how fast the stuff is moving, therefore making momentum a vector quantity as it has both magnitude in the form of speed from movement and direction. According to calculatorsoup.com, the momentum calculator uses formula P equals mv, or momentum P is equal to mass m times velocity v. Whereas according to khanacademy.org.uk.com, impulse is a certain amount of force you apply to a certain amount of time to cause a change in momentum. For example, when a basketball hits the ground, hits the backboard applies a resistant force for a short period of time, causing the ball to transfer its momentum in the opposite direction as the ball bounces off the backboard. As a result, the impulse is a vector quantity. This is because impulse changes both speed and direction of the given object, as the force applied to the object changes the object to travel in the opposite direction at a varying speed, creating both magnitude and direction. According to Zolan Education, an impulse is equal to the net force of the object times the time period over which the force is applied. Below we derive impulse from the equation mF equals ma, which comes from Newton's second law.